Where is the stereocenter in the molecule? None of these things are stereocenter because they always be two hybridized, right? Is that stereocenter? That carbon is two hydrogens. So if anything more than one copies, then that carbon cannot be stereocenter. So this is the only stereocenter, just like the aluminum. And then assign the absolute configuration. We're going to do the same thing. What's directly attached to the center? Nitrogen, carbon, carbon, hydrogen. So you can easily imagine that nitrogen gets the highest priority because it's nitrogen. Carbon, carbon. That looks huge. Should that get the second priority? It has nothing to do with the size, right? You're going to see what's attached to that. Carbon having one carbon and two hydrogen. That's what this carbon is. That one, two oxygens physically you can see, but it's double bonded oxygens. So that one gets the three oxygen bound to it. This one gets the one carbon, that one, and two hydrogens. So which get the higher priority between these two? The ones with the three oxygen. So that's get the second priority groups. Third is the whole thing in the bottom. Fourth is this one. So I'm connecting the priority groups 1, 2, 3. So that goes clockwise. So should I call this R? Okay, someone who says no, figured it out already. I forgot the very important part. What it is, put the fourth one in the back. Right now, where's the fourth one? Fourth one's coming out. You're supposed to see this screen from the behind. That's the where you're supposed to see. So this is what you see in the molecule, but you have to imagine that you're seeing from the other side. That's what your brain needs to process. I told you your eye is going to spin, literally. But there's an easier way. Put the fourth one in the front. What you can do, if the arrow rotates this way, if you look at the arrow from the other side, it comes in the other direction. If the fourth ones are coming forward, it rotates clockwise. If you look from the behind, it's going to look counterclockwise, so that becomes an S. So you don't have to redraw anything. You just have to consider that when you draw the arrow with the fourth one in the front, you just have to make the arrow go the other direction in the end. Sometimes people forget that part. So figuring out where the fourth ones attached is important. We're not kind enough to give the fourth ones always in the back when you ask the question. You have to see that, remember that, so you don't make a mistake. So this is an L tryptophan as S configurations. So we only did two amino acids by using the pattern. L amino acid get the configuration of an S. So does it mean that all amino acids is going to be S configured? If you kind of see that way, and this question will get you wrong. That's why that was there. That's for the cysteine, another amino acid. Let's put a sign here. That's a chiral center. This chiral center has a nitrogen, carbon, hydrogen, carbon bound to it. So easily, the nitrogen gets the first priority. This is the carbon, that's the carbon. So we do the same thing. What this has, we only see the two oxygens, but we're going to consider having three oxygens. What that has, it has a sulfur and then two hydrogens. If you kind of weighing it out, three oxygens should be heavier than one sulfur and two hydrogens. But it does not go by the weight. It's the presence of the heavier atom makes that one second priority. Even if it's just one sulfur, the sulfur is having a higher molecular mass, atomic mass, so it gets a higher priority, even though it's only one. If you get, we've been seeing that two oxygen gets a higher priority than one oxygen. It's all because they got oxygen there, so we count how many are there. But the one sulfur easily win the three oxygens because the sulfur is a heavier atom than the oxygens. So these get the second priority, that gets the third priority, hydrogen get the fourth priority, one, now two comes here. So it goes S configurations, right? So since there's S configured too, so all 20 amino acids should be S configured. If you say that way, you're forgetting the fact that fourth one's actually coming toward you. I told you that people make the mistake of not remembering the way the fourth one coming toward you. You're supposed to see the fourth one in the back, which is you behind the screen looking this direction. That's what you're supposed to see. So when you see the fourth one in the back, I don't know what you do. You make the fist or you put the pencil upside down, just trying to do that. To remember that, you got to flip the arrow back to avoid the mistake. Do whatever you can to remember the fourth one in the front when you see that. So 1, 2, 3, by connecting it without considering that, goes counterclockwise. But since it's coming out, we got to change back. So that's going to be the R configurations. So that's the L amino acid having a difference there, actually configurations. Still L amino acid, it's gonna be the same experimentally found, rotating the line in the left side, that's what the L means. But when you assign an absolute configuration, it gets a different assignment. The funny thing is, between the absolute configuration, which has to be the structures, how that actually measure it out, we still cannot calculate that thing. Even with advanced chemistry, physics, everything, that we don't know why. It still belongs to the relevance of experiments. If anyone found out, I guess that person can win a Nobel Prize. I mean, there are some tasks still need to be done. We still don't know yet. That does not mean that we will never figure it out. We just have to find it out more. This is kind of a question that you will see in the test. Not simple things like that. So what makes it difficult? This one. You can see that it's not small. I mean, it's size-wise, the other one might be bigger. But you can see that it's not simple. Cyclic molecule always makes it difficult. Let's do that. All the molecules we see before having a one steric center. How many steric centers does this molecule have? One. Sometimes some molecules have more than one, especially this one having two. One steric center there, the other steric center there. We got two steric centers. So that means that we're going to find out one for ROS, the other ROS. We're going to do this twice. So it takes time. All right, so we're going to do one by one. I mean, if you ever consider that one, this one, that one, like the stereochemistry, then it won't work because you're going to find out more than one copy of the substituents will make the stereochemical go away because you cannot find out the tie. So you cannot break the tie. So you will never work the other column. And these two, yes. Let's do this one. That one is carbon. Having a chlorine, carbon, carbon, hydrogen boundary. So which one wins? Easily chlorine, right? Oops. So chlorine wins the number one priority. And then there's a carbon and carbon. So we gotta break the tie. So then we're gonna count what that each carbon has. Each carbon is bound one carbon and two hydrogens. Right? This carbon has a one carbon and two hydrogen bound to it. That carbon has one chlorine, one carbon, one hydrogens. So between these two, which one is a higher priority group? That one with the one chlorine, right? So number two is this one. Number three goes to this. Number four is the hydrogens. And hydrogen is connected with the dash, which is where it's supposed to be. So then it's easy as connecting 1, 2, 3. It goes counterclockwise. So that must be S. If you just leave the question there, then you didn't do this one. So that's why you got to figure out how many steric are in the whole molecule. There's another one. So we're going to do this process again for the other steric center. For the other one, what's directly bound to it? Chlorine, carbon, carbon, hydrogen is almost similar situation. So you know chlorine wins, number one. Number two, this is the carbon. I mean, that's the carbon with a one carbon and two hydrogens. And this carbon has a one chlorine, one carbon, one hydrogens. So you can see that that side wins number two, and this side wins number three, and that's the hydrogen. So once you assign that, and you are happy, most likely you're going to jump in to draw the arrow. 1, 2, 3. It rotates clockwise. So most likely you're going to say, oh, that's R. Answer the question, move on. That is a part that I keep telling you. Remind yourself when you see the fourth one coming toward you. After assign length of the process of assigning actually, the priority, you are so happy, you just want to rush to an answer by connecting them by the arrow. You're forgetting fourth one's actually coming toward you. Then fourth one coming toward you. So that's why I'm telling you, do whatever to remember that whenever you get the situations. So if the arrow rotates without considering that, goes clockwise, if you look at the molecule from the back side, that's what we're supposed to see, put the fourth one in the back, then arrow should go in the other directions, that's S configurations, that must be it. Very easy to make a mistake. That's what we love it. The other ones is even more like it. Let's look at this one here. So far, you haven't seen many double bonds and those type of things. So now you're going to see that. How many steric cells in the molecules? Not this, right? That with the two hydrogen. Not that because double bonded it. Another double bonded it. That's with the two hydrogen. So only two. Right? So only two steric cells. Okay, let's do that. I'll do the one in the back first because the fourth one in the back makes things very easy. So let's look at this one, carbon, carbon, carbon. So all three are carbon. So we gotta figure out what each one has. This carbon has a one carbon, one oxygen, but then one oxygen is bonded with double bonds. So we gotta count the oxygen twice. So this carbon, we're gonna consider it has two oxygen and one carbon. This carbon, it has a one carbon and two hydrogen. That carbon, it has a one carbon and one hydrogen, but that carbon bound by double bonds. So we're going to consider this carbon with two carbon and one hydrogen. So now we need to assign the priority. The one with oxygen is the definitely better. So that gets number one priority. Number two goes here because that has a two carbon. Number three comes here, it's only one carbon. So number four is already in the back. So we got 1, 2, 3. So that goes clockwise. Should I rotate it back? I've been doing that all the time. No, because it's in the back already. So that's why you don't do that when it's not necessary. So that's the R configuration right there. What about this one, right? The front one. Now we have to do the front one. The one in the front, the hydrogen always get the fourth one. I told you there's nothing like the hydrogen in the periodic table. The fourth one is always the hydrogen if it's there. Carbon, carbon, carbon. So same thing, we gotta break it out. Let's go for one by one. This carbon has a one carbon and two hydrogen, right? This carbon is a one carbon and two hydrogens. Somehow you can tie. This carbon is a one carbon and a one hydrogen. If you don't count the double bond, you're gonna find out one of these two is over one or two. But since the double bonded it, that we need to consider the carbon twice. So two carbons and one hydrogen, that's what we consider it as. So that's the reason this get number one priority. Now, number 2 and 3, we still have to sort it out because it's the same thing. One carbon, two hydrogen, one carbon with two hydrogens. What we do, we go for the next position. This carbon for that side, that carbon for this side. So if you look at that one first, you got two oxygen, one carbon. You understand why that way come twice. If you look at that carbon, this carbon has two carbon and one hydrogen. So that wins. By that wins, make the whole thing wins. So this whole chain on this left side that's the one that get number 2. This vertically up, that's the one that get number 3. The one fourth one's coming out toward you. Told you that you cannot forget that. Very easily make a mistake. I told you after making such a long process of the priority assignment, you're so happy, you jump to the conclusion, you're possibly wrong. So 1, 2, 3. It goes counterclockwise. So it should be S, but again, the fourth ones are coming toward you, so that's not the right direction we are seeing it. So when you see the molecule from the back side, put the fourth one back, then the arrow will go to clockwise. So it is R. Need a lot of practice. You gotta make a lot of mistakes before the test. You don't want to make a mistake during the test. You want to make a mistake before the test. I just suggest do not apply.